Hi everyone, my name is Wael Abdelkader, and on the behalf of my team, I'll be presenting a quick overview to our study protocol, Auto Machine Learning Approaches to Improve the Identification of High-Quality Studies from the Biomedical Literature. On our agenda, we will go over a quick background, motivation, objectives of our research, our methods, results, and conclusion. Practicing evidence-based medicine have three main cornerstones, one of which is accessing strong evidence. And the exponential increase in the body of biomedical literature have been a barrier for accessing clinically relevant studies and high-quality articles. For example, in 2020, almost 1 million articles were indexed in Medline alone. Methods have been used to refine our search strategies and improve the access to high-quality articles, one of which is search filters, for example, the McMaster Hedges search filter and the PubMed clinical queries. These search filters, along with critical appraisal, have helped us create databases for high-quality literature. For example, Cochrane Library for systematic reviews and RCTs, the American College of Physicians dataset, and our McMaster Plus dataset. Although proven valuable and currently in use, search filters are limited by their dependence on search terms and mesh terms. Also, sometimes articles take up to a year to be indexed in Medline. Again, search filters lack specificity and precision when sensitivity is required, for example, during the systematic review process. And finally, critical appraisal process is time-consuming and require high level of expertise. And because of these limitations, the incorporation of machine learning were used. Machine learning is a subset of artificial intelligence, referring to the applications of computational methods to improve the performance and achieve precise predictions via experience. In this context, experience is the information given to the machine for its predictions. In the healthcare system, machine learning have been used to support clinical decision-making, disease prediction and early diagnosis, personalized treatment, medical insurance support, drug discovery and research, as well as imaging support. In the biomedical literature, machine learning have been used to automate the systematic review screening process. For example, Abstractor website also have been used for the identification of randomized controlled trials and strong evidence and high-quality articles from the literature. Machine learning text classification starts with data acquisition. In this context, it is the titles of an abstract dataset labeled by their class. The second step is pre-processing, which is bringing the dataset into a form analyzable by the machine. This is followed by feature representation, which is representing the dataset in a form computationally possible for the machine. Finally is feature selection, in which we select the features that will be used in our analysis, and finally the classification itself. Our objective is to evaluate the performance of machine learning models being trained using a large labeled dataset of high-quality articles for the identification of strong evidence for clinical consideration from the biomedical literature. In a series of experiments, we will evaluate the effect of various processes applied during the development of an auto machine learning model. Auto machine learning, or AutoML for short, are newer approaches that uses artificial intelligence to automatically iterate, select, and optimize multiple manual steps during the machine learning model development. This improves on the time consumption and improves on the overall performance as the machine optimizes itself for the higher performance. Our main research question would be how well do 602 machine learning classifiers perform in the identification of high-quality articles in a given dataset. in terms of sensitivity, specificity, precision, accuracy, and F-score. The first step is selecting a training dataset for the machine learning model, and we are using the McMaster Plus dataset, which consists of almost 100,000 title and abstracts for articles labeled by experts in the field based on their fulfillment of two methodological rigor criteria. The second step in our methods is the auto machine learning environment itself. We are going to use Microsoft ML.NET environment for our auto machine learning development, and we have selected 6 classifiers in this environment for our experiment. These are FastTree, 4 different logistic regression models, and the light gradient boosting machine. The reason we have selected these 6 classifiers are their capability of binary classification and the reuse of probability score as their output. In our experiment, we will be using multiple pre-processing steps combination, such as letter casing, number, punctuation, stopwords removal, and different weighting techniques, as well as different feature selection methods, uni-grams, bigrams, and trigrams, which are the sequence of multiple words, as well as dataset balancing technique, unbalanced, balanced, by oversampling and undersampling, and we're going to evaluate the effect of each of these methods on the overall performance of the model. Our experiments started in the second half of 2020, and we have used sensitivity to optimize the performance of our machine learning models, which is the proportion of correctly identified positives among the actual positive results. The specificity, precision, and F-score and accuracy were used to evaluate the performance of the machine learning models in comparison to each other. Our initial results suggest that when sensitivity was optimized to almost 99%, light gradient boosting machine achieved the highest performance among all 6 classifiers. Although they are really comparable and close to each other, a slight difference means that one list article will be missed. We have also incorporated the machine learning light gradient boosting model into our critical appraisal process. It has achieved an astonishing 98.6% sensitivity with 52.4 specificity, and only 3 articles were labeled as false negative. In our conclusion, auto machine learning holds a promise to increase the sensitivity without a substantial decrease in precision, and our additional study findings are anticipated to refine the critical appraisal process even more and decrease the workload on researchers working on the manual critical appraisal of studies. Thank you so much for listening.